Actually, this is a pretty cool chapter, I think. We're only going to hit 4 sections in chapter 3, and then that's going to lead into chapter 4. Chapter 4 is probably my favorite, and that's proving triangles are congruent. Now, I just want to tell you right now, this week's lesson might be one of the easiest lessons, in my opinion, of the year. I think it's really easy, but do me a favor. Make sure you do a good job on the homework and make sure you understand the definitions, okay? Because this is like the basics, and then we're going to build on that, okay? So just like when we did that crossword puzzle at the beginning of the period, some of you seemed like you didn't know what the words were. That puts you at a big disadvantage when it comes to understanding stuff, right? If you don't understand what a counterexample is, and then the question says provide a counterexample, that can be an issue. Now, what I'm not going to do is I'm not going to go through the PowerPoint that I did on my video, which hopefully you guys have watched. Just curious, who watched my video already? 3.1, at least part of it. Okay, so can you guys help me understand why you don't watch it? I mean, is it just that boring, or? I know it's not great, but that's what you're supposed to do before you come to class, right? Is watch the video. And the idea is you watch the video so that you got some idea of what's going on. Then when we come into class and we talk about it, we're good. So who can tell me turn my pen on here. Who can give me an example of 2 parallel planes? We've got a picture here, a 3-dimensional picture. Who can give me an example of 2 parallel planes? Liliana. Okay, so plane ABC. We need one more letter. You gotta give me 4 letters. A, B, C, D. So plane, and I'm just gonna write plane A, B, C, D. Okay. Anything else? We need 2 of them. You've given me 1. The plane she's given me here is this top plane, right? Does that make sense? What plane's parallel to that one? I agree. Does that make sense, guys? Now, guys, we don't know for sure that those planes are parallel. I'm kind of asking you to kind of just assume that they are. It's kind of like you would assume that the bottom of a box and the top of a box are parallel, right? This is probably a better way of using my resources. Thomas, can you give me another example of 2 parallel planes? I'm not going to write it down this time. She just told me basically the top and the bottom plane. Can you tell me 2 other planes that are parallel? ADE. Okay, so you probably say ADHE, right? The front. And then what other one? BCGF. Just keep going all the way around. You know what I mean? So go from here to here to here to there. Just keep going all the way around. Okay, does that make sense? Good deal. That's exactly right. That's excellent. Okay, good. Let's see here. Let's go with 2 parallel lines. Parallel lines. Let's go with Sean. Give me 2 parallel lines. 2 lines that appear to be parallel. AB and CD. Oh, by the way, I don't know if you guys knew this or not, but did you know that those 2 vertical marks like that mean parallel? Okay, so I'm trying to show you a little bit of notation here instead of me just having it typed up. Do you guys agree with that? Do you agree with what he just said there? Line A, B, and CD? Yeah, I think he's right. Okay, and let's grab Anthony. Give me another pair of parallel lines.
FE and GH.
FE and GH. Perfect. Ishmael, harder question. Can you give me an example of 2 skew lines? 2 skew. Have you ever heard that word? Uh-oh. So you do you have any idea what that even means? Can anyone tell Ishmael what skew means? Not screw, it's skew. S-K-E-W. Nope, not going up. Okay, so this is why it's good to watch the video, okay? Skew means two lines that are not parallel and not in the same plane. In other words, they're not parallel and they don't intersect. It's kind of tricky. You want to take a stab, or do you want me to give you an example first?
GF and AD.
Okay, so hold on. So he's saying line, let's do a different color. Line GF, thank you, sir. No problem. Oops, you said GF, didn't you? Or did you say GH? Actually, here, I'm gonna force you.
GH is good.
GH and what?
And,
So we're talking about this line right here, right? What would be one that's not parallel to that line and it's not in the same plane?
PC?
Yes, that'll work. That is true. So do you see how this line is down here? This line, BC, is up here. Would you agree that those two lines are not parallel? And they are not in the same plane? Can anyone tell me another line that is skewed to GH? What's another line that's skewed to GH besides BC? AD. AD would also work. AD is another example. Can someone give me one more line? I don't know if there is another one. I better be careful here before I say. Yeah, actually, there's one that if you can give me the next one, I think that's a smarty. Because there is actually there are more. Thomas? A what? A-E. A-E. Yes, A-E will work, correct. Good job, sir. So this one right here, that'll work. Liliana? BF. That's the other one. You got it. Okay, so did we learn something about the word skew? We don't use that word a lot in here, but we do use it sometimes. So what I wanted to go over is parallel planes, parallel lines, which, by the way, most of you seem to understand that already, right? So that's good. But we found out that we didn't quite know skew, all right? All right, now I'm going to go. If you haven't watched the video, you're going to be at probably a big disadvantage for this. Can anyone give me an example of alternate interior angles? In fact, I should probably write that all the way out. Let me do that one all over again. Let's do that again. So alternate interior angles. And I need to mention one other thing. This right here, I'm going to say this line right here, I'm going to call line R the transversal. The transversal. Can anyone tell me an example of alternate interior angles? 6 and what?
6 and 3.
6 and 3 are not alternate interior. Okay, so I'll guide it. Who can tell me what angle is alternate and interior to angle 6?
4.
No. By the way, what are angles 6 and 4? Vertical angles, Anthony says. Correct. Anthony, that's a smarty. Good job, dude. Who can tell me what angle is a alternate interior angle to angle 6? So you guys have no idea because you didn't watch the video, right? So here's the thing is you got this guy in front of you who's getting paid big bucks. I make videos. In fact, the video I made today, in fact, here, let me just show you while you guys are working on the quiz. Let's get out of that. I'm going to keep my ink there. And I'm going to go to Cam. By the way, I was watching you guys while you're taking the quiz. Let's see here. Courses, geometry, module. Let me explain what's going on. Now, guys, I know you're not teachers, but I want to explain you what's going on. Before this year, when you went into your math class, your teacher might just show up to class with handouts and give you handouts, right? So here's what I was doing, and I actually started this process yesterday. I'm not talking about October. I'm working on November 2nd, the week of November 2nd. So yesterday, guess what I did yesterday? I made a video. I'm not going to show you the video right now. Actually, I'll maybe get it started. I made a video on section 4.2 and 4.3. Okay? Now, I don't care about the video, but that took me a while to do. So I made a video. And then while you guys were working, I then started adding extra videos as extra resources in case you didn't understand my video. If that wasn't good enough, here's 4 more extra ones. And then I created the homework. I went through and I selected which problems I thought would be good problems for your homework for that week. And then I went through the textbook and I figured out what would be good practice problems to do. And then I got to add some more to this because you guys got a quiz the week after this. So I have to come up with a review for you guys for this quiz. That'll be the following week. Now, why I'm telling you that is this. So this week, which is week 8, that's this week, you guys had a test. And be honest, how many of you actually kind of studied for the test? You kind of did some stuff to make sure you're ready for the test. Okay, a few of you did. Some of you didn't. If you didn't do anything for the test, do you think you could have done better if you had prepared for it a little bit? You probably could have, right? Do you think right now when I'm asking you this question about alternate interior angles, if you had just taken 10 minutes to watch my silly video, that's basically me just explaining stuff, but it's still me explaining stuff, you'd probably be able to, it's a very easy question, but you have no idea. So I get a little frustrated because I feel like I'm doing all the work and you guys aren't even doing the stuff that I'm asking you to do, which, by the way, do you guys think I give you a lot of homework or not a lot of homework compared to other math classes? Not a lot. Very light on the homework, really, right? So you gotta throw me a bone. I'm throwing you a bone, throw me one back. So let me explain what alternate interior angles are. First of all, let me talk about this right here. Oops. Okay, this thing that I said is a transversal. All a transversal is a line. It's a line that intersects two other lines. Would you agree that this line intersects this line and this line at those points? That we're going to call that the transversal. Now, can you guess what alternate means? Alternate means on different sides. Can you guess what interior means? It means on the inside. So here's what alternate means. Alternate means if this is angle 6, I'm telling you it has to be on the other side of the transversal. So it can't be 5, it can't be 7, and it can't be 8, right? Because those are all on the same side of the transversal. So it has to be either 1, 2, 3, or 4, right? It can't be 4 because Anthony already mentioned that's a vertical angle. We've already talked about vertical angles, and it can't be 3. Guess why it can't be 3? Guess what 3 is called with relationship to 6? It's called a linear pair. Do you remember us talking about linear pairs? Yeah. So it's not 3 or 4. It's either 1 or 2. Which one do you think it is if it's alternate interior? It's 2. And let me explain why. First of all, would you agree that 6 and 2 are on opposite sides of the transversal? Yes. Would you agree that angle 6 and 2 are kind of inside of angle or lines? Does that make sense? The name of the angle kind of explains what it is. Did I do a decent job of explaining that? Okay, that's what I tried to do in the video too. Okay, it's probably a lot better to see it in person though, right? Okay, so angles 2 and 6. Oops. Are alternate interior angles. Can someone give me another example of alternate interior angles? Ronan, can you give me another example of alternate interior angles? 7 and 3. Ronan, you just learned something, buddy. Wasn't that difficult, was it? It's not really that hard, but you have to be disciplined enough to make sure you understand what's going on. In another week or so, we'll have a quiz on this. Was that a hard question to answer? Not really. But you got to know it. If you don't know it, then you're like, gosh, I don't remember what that means. Then it's hard. Okay? So those are alternate interior angles. I need to check my time. Okay, so let's do same side interior angles. Can anyone give me an example of same side interior angles? Same side interior angles. I'm going to erase these guys.
6 and 3.
No, 6 and 3 are a linear pair.
6 and 1.
6 and 1 are not anything. Nope. Liliana? 2 and 3. Hey guys, look at angles 2 and angles 3. Would you agree that they are on the same side of the transversal? Would you agree they're interior again? That's same side interior. It kind of makes sense, doesn't it? Can someone give me another example of some same side interior angles? Sean?
7 and 6.
7 and 6. Was that hard? Not hard. Okay, so let's see here. Let's do a different color. Let's do alternate exterior angles. Now, don't say it out loud. I bet you can look right now and tell me an example of alternate exterior angles. We already talked about alternate interior, right? Wonder what alternate exterior angles would be. Alternate exterior angles. Now, let me erase this. Alternate exterior. Vaughn, way in the back. You got any idea? Alternate exterior?
In the same line?
Say again?
In the same line? Like,
So like up here, alternate interior, I had 2 and 6, like these two guys here. Can you give me some alternate exterior angles? 2 angles. I'll give you a start. Angle 1 and angle what would be an alternate exterior angle?
angle 3.
Nope, angle 3 is not exterior. Alternate exterior angles, not it. Those are linear pair. Liliana.
1 and 5.
1 and 5. Yes. Now let's explain that. First of all, would you guys agree that 1 and 5 are on alternate sides of the transversal? Would you agree that angles 1 and 5 are on the outside of M and N? Alternate exterior angles. Who can give me another example of alternate exterior angles? Another example of alternate exterior angles. Thomas. 8 and what?
4.
Correct. Angles 8 and angles 4 are also alternate exterior angles. Are we good? Okay, I got one last thing here, and then we will wrap this up. I'm going to check how our time's doing. Okay, let's do purple. Last one, we're right up here. All right, the last type of angle we got to do are called corresponding angles. I think I might just explain this and give you an example of this one. And then let's see if you can figure it out from there. I'm going to give you the answer, and then I want you to see if you can figure out what the connection is. Angles 1 and 3 are corresponding. Who can give me another example of 2 angles that are corresponding angles? Ronan.
8 and 6.
Correct. Who can give me another example? Thomas? 7 and 5. Who can give me one more example?
2 and 4.
2 and 4. Guys, that's it. And I'm going to go ahead and stop my video here because that was way longer than